Hello, hello. How's it going? Ugh. I swear, computers. Computers. I have been slowly switching over my Wi-Fi, and my key light stopped working, and then I was dealing with that, and my cat is incredibly needy right now. Say hi. No, nothing. You were just talking so much before. And then I pressed the wrong button, and I think I borked the other stream. Whatever. It's Tuesday. I swear, nothing seems to ever work. One of these days, I'll finish up this like ongoing stream of to do things and have everything in a good place where I can press the button and just go and it all works. Stop licking that green screen. Anyways, folks, how are you all doing? Hopefully, your morning is going better than mine. I'm scared she's gonna knock the green screen over. Come on. If you want attention, come up. She likes to lick random stuff, which is really weird. Love her, but at the same time, sometimes. All right. We are sort of starting a new stream of work here. All right. Yes, if you want attention, come up here. I'm clearly a little scatterbrained too. Working off a not great sleep. The youngest was having nightmares, so that's contributing. Anyways, so if there's lots of digressions today, that might be part of the reason. We are, and we've touched on this idea in the past, and I've sort of been jiving on this idea for, well, honestly, more than a decade at this point. But I feel like things are finally starting to pick up, and they're getting to a place where it's actually you can start building an app rather than working on the infrastructure to then build the app. Come on up. Come say hi. Why are we so needy today? So the idea here, come on up. I need to cut her nails. And she'll like paw and scratch at me if she wants, like when she's super needy. Little pin needles in your kneecap does not feel great. So, anyways, local first apps. The idea here is that it's in the same vein of, but probably like 6 years ago. I feel like offline first sort of came a little bit more into the zeitgeist, as it were, and the idea with and this might be a little bit more in the like web tech area, but offline first was more of the idea that you had some expectation of, rather than relying completely on the server and doing every operation through the server, you would cache some of the data locally, and you would do operations that had some expectation of immediately showing to the user and then going out to the server in the background, doing its work, and then coming back and like resynchronizing if you need to. Now she's looking the other side. Come on, what is your deal today? Kitty is not so that idea. Anyways, I keep getting distracted by the cat here. The idea of this do work locally and then synchronize with the server, check with the server. Optimistic first updates or optimistic updates might be a term that you've heard before. And okay, really? I'm gonna have to like lock her up or something, maybe. She's biting the green screen now. All right. Sitting on my cord here. Okay, we're gonna go cuddle cat mode. Now, the idea of local first is sort of taking this a step further, where you actually house and sort of own the data. There's a little bit more around the data ownership, which is good for your like privacy concerns. Okay, seriously. Come on. Get over here. I'm gonna have holes in my green screen. Why? Why? I told you it's one of those days. Okay, so the lots of background here we've given. Today, though, we want to talk about Automerge. I think one of the things that really like kicked off and solidified or gave terms to this idea of local first apps was an article by Ink and Switch, and out of that article or out of that like research area that they've been going into is a library called Automerge. I'm pretty certain they're related, but we can double check on that. Now, what's interesting specifically with Automerge and Tauri, Automerge has an implementation in both JavaScript and Rust. So in theory, that syncing mechanism, the way that this library works is that rather than you loading a page and doing a post or a GET request to an endpoint and then showing data with some caching, the idea more is that you sync and you're pulling down the data and you have all that data locally. And it's more of a rather than you pulling data down from the server, it's more of a push. The data, when there's updates, pushes data to the clients, and then the clients are do their own work potentially locally, or do operations that the server is sent to then get that local data into the appropriate state. Now, with this architecture, and I think with a lot of these discussions, it's very much been around the idea of browser and server implementation. I think what's particularly interesting about Tauri, and in some ways the fact that the backend is in Rust, is you can kind of have that act like a server. And I haven't really seen any folks talk about that idea, and I haven't seen too much experimentation with that. So, very, very long story short, I think there's some unique implementations, specifically in the area of local first, where we can look at having the Rust portion of Tauri act or serve as a sync mechanism, to where rather than using the method of having a user stand up a Docker container locally on their local network, for like those folks that are very interested in data ownership and privacy concerns, you'll see apps, especially the like open source sort of user focused apps, provide an option where they can stand up a Docker container locally. that's a big ask for like it's basically saying that you need to have some potentially long-standing background in programming to be able to have any to be able to value privacy and value data ownership, which feels odd to me. So enabling that idea of I want to own my data, but I don't have a degree in this, or I'm interested in these concerns, but I don't have the time or interest in like standing up a whole thing locally. But if I can just open up an app and run an app and make sure that that app happens to be running on the same network as another device, like that idea really is interesting to me. So well, we're going to go through Automerge. We're going to play around with it a little bit. I don't know how much we'll be able to dive specifically, or at least deep into that idea. But we want to explore it at least, and this is probably going to happen over a handful of streams. There are probably 3 to 5 libraries that are sort of in the vein of Automerge, and then a whole bunch of additional ones that are more server dependent, and then they have services usually that are intended to be, you know, like work in tandem with, some of which also have like hosted options that you can like pay the company that is working on the code to also host the thing for you. So we're gonna explore the space. It's not gonna be every stream. It's not gonna be something that happens like in the context of 1 or 2 streams, but this idea and integrating it with apps, I think is something that we're going to explore over the next handful of months at least. Okay, so we've dug into it. I was gonna do the let's just switch over here. I got a couple things up. I was going to put it in the to do, but I've been like so scatterbrained today that we're not gonna bother with that. Instead, actually here, I didn't even open up Chrome. Let's open that. I just wanted to do it on the side because I don't remember what I had open, etc., etc. Okay. So we had actually, and I've been slowly working on this upstream, but we had worked on 2 pieces for our to-do app. The ability to sync up the icon state to work with the positioner plugin, but also additional options on that positioner plugin, which are, oh, here I just have it hard code 15. That they're in process. I got one of the PRs open, but these types are there's I think Amr actually is tackled most of it at this point, but I don't think this event is quite right. Long story short, we'll get that going. I'm going to close that for now though. And we want to look at Automerge. Let's Automerge JS, I think will work. There we go. I think if you search for Automerge, it's not specific enough for Google or my search history on this this browser. Cat hair flying around in front of me. All right. Does that look dark to you? Is that just I feel like my display, it feels slightly off. And also there's a corner there that is why? I swear. I don't know why that's showing up. And that is going to just bug the heck out of me. Why is it doing that? There we go. All right. Okay. Yeah. I don't know if it's just something with my monitor, but it looks darker. Like desaturated the screen share part of it. Okay. Unhinged. The stream is, I swear. We do have a repo called local first at Playground. I have no recollection what we actually have in there, to be honest. We're just going to close all those things because I want to look. We have Vite. We have. Okay, so this looks like the when we were playing around with Tiny Base. And I actually also have star effects in here. What were we doing with both of those? I'm provider. I don't think we actually use star effects in this at all. SQLite store. Okay, yeah, this looks. It looks like we were experimenting a little bit with like trying to combine these together. I don't think that is actually something that we want to continue to go down. It actually looks like we never pushed this up either, which is very interesting. If we look at our repositories, can I do public? There we go. I want to make sure that I don't think I have anything private on this account, but we've got Tauri Playground, personal tray app. This is the template that we've been slowly working on to basically enable tray apps. I'm really tempted to rename. I don't know if I like the personal tray app. Anyways, distractions. Yeah, okay. So I guess we never pushed this up. I don't know if I'm actually even signed into this. GitHub. Because we can do from here, there should be a create, I believe. Issue, git, release, repo. Because this like isn't even a Git repo. All right, we're actually just gonna start a fresh thing. I don't think we actually. If we look at the playground, Tauri Playground, sure. Did we do have a local first data here? Okay, so got it. We were actually experimenting within our Tauri playground. Should we keep it there? All right. I'll tell you what we're going to do. I thought we had a repo already rolling for this, but what I'm going to do is I'm going to create a repo called local first. I don't think I'm going to bother committing this because this seems in sort of a tenuous state. And we'll say type, okay, JavaScript, no, JS. Node, all right. And I'll pull that tiny base stuff over, I think. But for now, we'll just roll with this. And in here, we will start with the Automerge. Git clone. I should. Ooh. And local first. And let's open that up. Okay, now we are going to, I think we start with a Tauri app because we're talking web. This is going to be web, or there's going to have some expectation that you're running stuff within the web or in the context of the web. Hey, Nicola, good to see you. So considering that, if we create a Tauri app, we sort of have the option, as long as we don't do any deep integrations with Rust or with the Tauri APIs, that would theoretically work both in web and within the Tauri app. So I'm going to go ahead and we're going to use this time. Switch it up a little bit every time. Yes. We are going to call it, I guess we just call it Automerge, eh? Sure. This would be TypeScript, sure. We're going to use npm. Most of these, you'll find if you dig into JavaScript implementations that are in CRDTs, local first, any of those like things in this category, they all seem to have an integration with React. And I think that's in part because it's a numbers game. They're working on sort of the front of the back, or the back of the front rather, where you need the code in the browser, but the view layer doesn't matter too much. But if they make an integration with React, that's going to like check a box for a lot of folks. So I think most of these are probably we'll probably just start them with React. In part also because I'm much quicker at React than I am with other libs. So we are going to go into Automerge and we are going to npm install. So first off, we want to there's a quick start repo. We might actually want to look at that so we don't have to set up too much. And there's a bunch of different packages on top of this. So, so something to keep in mind. But what we want to, yeah, I think we're actually I think we look at this because getting to that stage real quick so we can start talking about it and playing around with it, I think is going to be helpful. And integration wise, I doubt that there's going to be too much that we need to like really play around with. I guess those will all be fine. Oh, this is the other interesting bit. So this is set up with Vite, which is helpful because I believe the thing we also generated is set up with Vite. So copying and pulling this over is not going to be as big of a deal. We need to, if a library is written in Rust first, it tends to then have a WASM build to enable working within the browser context, which is potentially both a good thing and a bad thing. But in the case of Automerge, it is, I don't know if it's Rust first and then they generate the WASM, and that's the integration. There is, I think, still a little bit of work in JavaScript though. So, but either way, we may need to pull this plugin into our code because we're also using Vite. Oh, that kind of triggers me a little bit. Actually, those will. I like to alpha cert them. I don't have a strong reason for that other than it seems to make sense in my head. I want to double check. Okay, so there is a newer version, 2.1. I'm guessing it looks like these are all versioned the same. So we're going to do that. We'll do another npm install because we're going to need to get those. And let's start pulling over a little bit of code. And as we are doing that, we can go through it a little bit. And you'll see the layout and the setup is pretty similar because it's a Vite app. We have React, we have app. There's a type in here. We are pulling in a bunch of the Automerge dependencies. They have a WebSocket client adapter. This is interesting. We might want to like look into that a little bit. Yeah. Does it say anything about that? Okay. Okay, well, it does feel a little bit odd. I think we'll just end up copying it over though. And I don't really care too much about the other bits, but I think we can just straight copy this. Root doc URL, Automerge URL. So it looks like there's some dependency specifically on the routing, which is interesting. We can kind of dig into that a little bit. And this will go in here. So you'll see that we aren't changing too much. And this is likely throwing an error because our app doesn't accept it yet. So we need to go to this. We do have in the default thing from create Tauri app, the default command. I don't think we actually need any of that for right now. So what I'm going to do is just copy all of this over the top, and I'll copy over this CSS as well, just so we're all on the same page, and it's going to look like we expect they're getting started to look. This is the index CSS. Okay, we don't have an index. Index CSS, where are you imported? In the main. Okay. I'm going to call it a main.css. And then in our main here, I'm going to switch that to main. And we are going to go back here and say app CSS is this. All right. Now, if we do an npm run Tauri dev, we will get a... okay. Do we care about that for right now? Pico CSS. I guess we can pull that in. I don't see a reason to specifically fight their original choices. I'm gonna grab this and we will drop it in here. Same version of React, so we're good there, and we'll do that. We are getting a Rust build, so I'll give that a hot second to resolve. It looks like we might have gotten a little bit of outdated Tauri depths, but that probably is not a big... Why aren't you not scrolling down? Computers today are just not cooperating with me. We get an error, which makes sense because that's the... I guess we could pull the logo. Well, no, I'm not gonna bother with the logo. Well, let's remove that. Automerge logo, image source. Okay, we'll get rid of that and get rid of that. And then we will need to do an npm install again, and we'll rerun it. And that should hopefully give us a good build. I'm gonna start playing around with it. So the okay. We do actually have that installed. Whoop. Cancel button. There we go. We do have that installed. We did pull in Vite plugin Wasm, but we did not touch our Vite config, which would be an issue. So if we look into their Vite config, you can see that they've got plugins Wasm, and there's a worker. Okay, so it's a worker. And that's under define config server. Okay. Oh, wait, what? Define config, base, build, plugins, and worker. And there's a server here. Worker. So why do you not like that? The last overload is declared here. It might just be because we don't actually need that to be a... Oh my, all right. Okay. Plugins, format. Format is ES or IFI. Okay. Type has no properties in common with type user config. Okay. I mean, it seems to be valid. Do we need this to be async? I don't think we actually need it to be async. I don't know if... All right. Okay. I'm not sure what's the deal with the types there. It could very well be a mismatch on versions or something. I'm not going to worry about it too much, though, because we just want to get it working. All right. ESM integration proposal for WASM is not currently supported. We are using it. Is there another place that we need to do it? Base. Ah, okay. There's in plugins as well. Got it. So here. Hey, here we go. So now if we do new task, hello. Interesting things. Okay. Seems to be working. Now the question is, we have a demo that we can look at. It is, if we want to, like, starting up another instance of this is actually going to be kind of difficult. We could, because we don't have anything that's specifically dependent on Tauri at the moment. If we open up this in the browser, we can potentially, and see, this is starting to dig into, I'm not going to say that local first is hard, but the DX around it, it's definitely going to take a little bit of oomph to get it to the point where it's catching up with what the web is doing. Things and stuff. Because now if we clone it here, we still get it. And we can actually do just like their demo. I'm presuming if we check this off, this one updates. So they are kept in sync. And if you did this in a normal like spa, that functionality to keep it in sync, I would say the default probably is still dependent on a server. You make a change that changes central to the server. If you open up a new tab, when you hit the page, it pulls that data back down, and that's, you're always hitting the server for information, and that's how it's kept in sync. With caching and optimistic first updates, you're still doing that, and you're still depending on the server to keep it in sync. But it gets a little bit more complex. So if you're caching it in local storage, when you load up the app in another tab, they could both be potentially writing to that same local state. And then when do you persist, save back to the local storage versus when do you pull from it, that starts to get a little bit more complex. That same consideration, though, is something that you also start having to think about when you do these other more like local first libraries. If we look at these, we have repo storage IndexedDB, React hooks, and network WebSocket in repo. This appears to be using a I don't know if that sync mechanism is actually being used yet. But I'm imagining that if we look at our dev tools, we would be able to see application and IndexedDB Automerge. So it's saving it back to IndexedDB. And that is sync state. this information is what's used to derive basically the state. I don't think Automerge is serializable, so it's not like a plain JavaScript object or a plain array, because it's like keeping track of this as a way to derive the state, and that is the piece that's being synced. So then every client can derive their state based off of these same like list of events. Let's confirm that. Yeah, it's an immutable snapshot at one point in time. You get a new state object reflecting that change. So we can see this. And you can see some of these match up. Not Q9, Q9, and then these are different. So the Rust implementation compiles the WebAssembly. It says the JavaScript implementation is compatible with Node.js. I don't know if that means the WASM compiled version. And actually here, this is that article I was talking about, which is very good. Drop it in the chat there. Let us look at yeah, so library Node.js, you don't need to do anything special because it supports WebAssembly. But if you're building in anything in the browser, you need to be able to handle WASM. A transport agnostic sync protocol. And works on a per document basis. So we have one document here, and like this is the sync mechanism basically, or the sync protocol. Every time you make a change, it's generating like this data, and it's using that as part of the sync. And we can use multiple storage formats, which is interesting. And a compact binary storage format, which is why this isn't the actual like, it's a binary representation of it. Key and binary. Key. Very interesting. Okay, and a repository URL looks like that. So if we look at, let's look at the welcome. I want to double check. So this in general is a CRDT, conflict-free replicated data type. The idea of, and one of the, it's probably the CRDTs are probably the most useful when you're doing, you'll see it most often when you're doing text, and especially when you're doing text in a multiplayer way. That is, you can think of a Google Doc, multiple people editing one document, and it's text based. That design or that space gets complex really fast, because if you consider each word in an array, if somebody edits this paragraph, somebody edits this paragraph, making those changes becomes very difficult. Especially when you start going, well, I want to, if I'm sending every stroke of the keyboard to the server, that's going to be an awful experience. So you need to do some local stuff. And that is, I think, mostly what spawned this idea of how do we think about this and how do we have multiple changes and handle multiple changes and then sync them and get them all in a good place without running into conflicts. Conflict free, replicated, meaning my inputs are then replicated in somebody else's state. So when I make a change in the Google Doc, or I make we'll just say doc, I make a change in the doc, it gets sent up to the server and back down to another user. Now that that data is replicated in their instance as well, in a conflict-free way. So it's a bunch of math, I think, actually, which is able to determine effectively the sync mechanism. So all those like complex, what if this situation, what if this situation, ideally it just deals with it for us, which is lovely. Now I wanted to check to see if, I don't know if it's actually going to specifically say it. There's sort of two ways to do that. I don't remember if they're both considered CRDTs, but there's like an event log, event source, I think is the term. And there's and that's basically like a log of events. You make a change and it continues to like maintain that log. And then there is every time you get an update, you do the CRDT mechanism and it's just like immediately. I think we're gonna have to put a pin in that. I don't know which one Automerge is offhand. I don't think it's the event-based one though. But I don't. Okay, under the hood, merge rules. I don't know if their docs actually say anything about this. Storage glossary. Yeah, each change is dependent on a previous change, which means that all replicas are able to construct a history of the data structure. There's specific terms for that, and I don't know which one Automerge is, so I'm hesitant to specifically say. So like CRDT, I think is a more of an umbrella term, and there's ways to handle CRDT mechanisms. Here, read more CRDT.type. Ooh, what is this? I haven't seen this one before. Okay, this might be. Yes. So strongly consistent replication and optimistic replication. And then in part of this too is they say CRDT support a decentralized operation. There's also like centralized versions of these, which tend to. Here, well, let's actually. I had another doc. Where are you? Is this gonna? I think I copied the right link. Yep. Here, we'll share this as well. I was actually just watching a video on this yesterday. Johannes, from the person that worked on Prisma, I believe it was. They have a podcast that's actually on YouTube as well. And they interviewed the person that wrote this article. And this is specifically for if you have a central server to handle that collaboration. So in some ways, it's not applicable to specifically the like subset that we're interested in. But also, if you think about it, you could use the Rust backend and think of it like a central server. But then also, essentially, you could have multiple central servers. So if every device had this app, like if you had two, a MacBook and a Windows PC, now you basically have two servers, and the servers need to sync with each other. So operational transform. Okay, so I guess they basically categorize it as server reconciliation and CRDT. But then like it's an asterisk. So both Automerge and YJS don't actually need a server. And yeah, CRDT-ish and OT-ish. And that's I think probably the there's the research and the like it's the idea too of you design a spec, and then that when folks go to implement the spec, there's little subtle differences potentially. So like you have a spec for the web, but then the browsers all implement their own thing, and some of them are implementing ahead of the spec, some of them are behind the spec, some of them are, there's those little subtle differences. And CRDT isn't like a specific spec either. It's sort of like a research area. So now you have both a loose spec, and you have sort of math and ideas behind that loose spec, and then you have implementations of all of those. So you have different like ways to actually implement these things on top of that. So the CRDT-ish is probably a very good explanation for it. It's a type of CRDT. I'm trying to remember where I heard somebody gave a good representation of all the different sort of categories, high level categories, and like what each of these libraries fall into. I need to find that again. I had it close at hand at one point, and I've since have no idea what I did with it. But their representation of it was really good. Okay, so basically, long story short, here is that we have let's close we have Automerge, and we have you can see like the IDs are different. Each browser instance, so the actual Tauri app itself is like a browser instance, has its own instance of IndexedDB. So we have an Automerge document for this site. So we have one that's on localhost here and one that's on localhost here, but they're in like different browser contexts. So you get also a different, like those are completely separate docs. So when you think about it, this mechanism in tandem with me duplicating the tab, that's not necessarily a sync functionality. That is a replicating it to or persisting it to IndexedDB. So when I open this up, it is pulling it from IndexedDB. The sync mechanism, though, that's happening is I think it is like listening to changes in IndexedDB. So when I make a change here, it shows up here because this is also subscribed to like that IndexedDB instance. This is not. That's why it is not updating. So you actually get this sync mechanism happening over IndexedDB, and it'll happen across tabs in the same browser. But as soon as you move outside of that, like an app versus within a browser or even like devices, those aren't going to sync. So you need a different sync mechanism to get those to match up. So if we look at storage is sort of this first piece, IndexedDB. You can run a repo without a storage adapter. It'll have to load its data from remote peers on every restart. So you need like a server or peer-to-peer type thing, this to be existing for it to first load. The storage adapter enables you to load from the file system and then do the syncing. And you can see there's also a file system implementation, which is potentially interesting because we have access to the file system in Tauri, or at least more direct access than we might have with something like the browser. So the next bit of this is networking. WebSocket network adapter has two parts. So we have a server running a WebSocket, and then we have a client. And this client is connecting to WebSocket. And that's the sync mechanism for network. And we do have this installed. Let us see. Is it actually? Okay, so it's pointing to sync.automerge.org. Let us actually, I'm assuming that they're going to handle HTTP as well. So if we do HTTP, we'll say S. Running. Okay. So they are, but not in a terribly helpful way. Can we, let's see. Nope, that's a type doc. I don't really need a type doc. I want to look at and see WebSocket here. So they got some information about how it handles all the syncing and et cetera, which is, this is actually pretty good information, it looks like. I just want to know what that, I want to know what the URL is for. It doesn't actually say anything here. And it didn't say anything in the getting started docs either. Can we go to I like this, a builder's tour of Automerge? That is, I just want to get, I don't want to read, I just want to try it out. Do they actually mention the URL in here anywhere? Storage and network adapters. Okay, this is sort of what we're going through right now. Broadcast network adapter. I skipped a collaboration over the internet because I'm specifically interested in this. All right, here. Now, when a repo sees any changes, it will sync them not only locally via the broadcast channel, but also over a WebSocket connection or any other process that connect. So this is a public sync server to experiment with, not private. Feel free to use it for demos or prototyping, but otherwise you should be running your own thing, which makes sense. Unlike the local only version, you'll now see the data updates synced across all open clients, which is interesting because these should be the same. And like part of this might be an issue with this. How do we get it to actually do that sync? Like if we already have it enabled and it's pointing to this public instance, got a repo, create. So this is the task list, and document that location.hatch. So the doc URL is going to be this hash. And the URL is different. So that's probably the biggest difference here, is that if we plug this out, console.log root doc URL. So this is our doc URL here. If we go into this instance and we reload, different doc URLs. And part of that is because this is at localhost 1420. This I think technically is as well, but you have some Tauri stuff potentially happening in the background that means that they don't line up. And actually, I guess now that we see that, if it's doing it based off of the root URL, if we turn this functionality off and we are just syncing through IndexedDB, does it actually do the sync mechanism here? So we open this up, they match. If I do a new task here, hello, you can see that it actually didn't update here. So the storage doesn't handle any sync. I was wrong about that. The mechanism is more around the persistence. So storage is more to persist the thing and pull in basically like an existing state. Instead to when the client loads, grab an existing state rather than trying to start fresh every time. But it doesn't actually handle that sync mechanism at all. So the sync mechanism that we were seeing was indeed this browser WebSocket client adapter running through this public sync mechanism. But the doc URLs are different. So let's log out a little bit more so we have some things to work with here. We'll say hash and all right. So we've got a location and it is using the hash, which appears to be something related to Automerge. So it must actually be doing something with the URL, which, I mean, I can understand why or what it is doing, but so it's actually changing the history. So it must generate a hash on load, and based off of some context, it's generating the hash consistently every time. So is it happening here? That is probably the biggest question. If we take this bit off, we don't do any of the, I mean, this might not actually, well, we can do this. We'll just do an empty div. Now, if we do a clear the console and let's reload, we're still getting that hash. So what is doing that hash? We're not importing anything here in main and an app. We're not actually importing anything in app anymore. This imports from main. Is that set somewhere? Refresh, delete database, delete, sure, delete. I want to refresh. What is setting that hash? Module root. Is it doing that just from the fact that I'm importing it? Refresh. If we look at Vite, Vite is pulling in Wasm and React. It's not actually doing anything specific. It's not doing anything specific to Automerge. We have an app CSS. We have an app .tsx. And we're not actually loading anything in here anymore. Root doc URL substring 1. So what's actually setting that hash? If we that route. So when it's first loaded, it's actually sticking a hash. If it doesn't have one, it must be sticking one on there. We don't have like direct visibility into the actual document location. Like you can see it's just appended there, so that it's pulling out of the actual hash. So when one of those libraries loads, it is setting that hash. So the question is, if we wanted to get instances talking together, how do we actually do that? And like this also flows into like privacy type stuff too, and data ownership, because if this is tied to a hash and that is synced through, like in theory, somebody could duplicate that hash and then they just start getting this data, right? Public sync server, so keep that in mind. It's doing that sync naively. So if you implement a sync server, you would have to put in your own like permission checks and such, and it would that mechanism would then be the way that you don't accidentally leak other folks' data. But this also means that it makes our setup a little bit more complex, because I don't know what's actually determining what determines that hash. Library initialization. Okay, so there's a initialization piece using raw assembly. Escape hatch deno vite. So when we define that, it is it must just include it in there. So it attempts to import it, I'm guessing, when we here, this is going to be our example here. We've got the localhost. Here, let's do this. Whoa, what was that? Some weird snapping stuff in Windows here. We have a bare URL. If we import, I'm guessing we only really care about this one. So if we import this and we do a refresh, it's not actually setting anything. If we then do this without either of these and we're just instantiating it, and we do a refresh, nothing. I didn't think we actually needed an adapter. So document.location.hash. So basically this is doing a check here. If it's a valid URL, then it finds it in the repo. Otherwise it creates it. So I bet you this create functionality here is probably the, yep, there you go. So when we call repo.create, it is generating an Automerge hash. So now let's look at that. Let's look at that API. Whoop. And this ends up being the, like if we look back at this, tools marked with an asterisk also work in the absence of a central server. We don't have a central server. It is dependent on the hash in the URL, using that as the mechanism to determine, you know, like what is this doc building on, and does it need to pull from an existing one or something. So if we look at their API docs, okay, all right. Automerge? Is this, which repo is that? Is that literally repo? Yeah, it's repo. And you can see there's actually two. If we go back here, and let's look at JavaScript packages. It says install both of these, and then the networking ones. There's some updates in Next as well, which sure, fine. Okay. Core Automerge libraries. So it's not super obvious when you're making it. You should use the Next API. I don't think functionally it's gonna change much of what we specifically care about, but it looks like we would want to use the Next API. Which, let's see, Automerge, well, like we're not using any of these directly. So I'm suspecting that by using this, it's defaulting to the Next stuff. The Next API exposes the diff and change methods. So like if we looked here and we said a repo.diff storage ID peer, we might actually be using the next one. I think that's fine though. The big thing is we want to look at API docs, and if we look at Automerge repo, Automerge repo, and we do a repo, that gives us access to these. So there's a create, and this creates a new document and returns a handle to it. So it's an empty object unless initial value is provided. We are providing initial value of tasks. Its document ID is generated by the system. So it is generating an ID. Can we actually set that? That would probably be the next thing that takes an initial value. So it's just generating an ID. It just does it for us. and is doing some work to find it, which, okay. So we might be able to hack it. If we say, here, we have a hash. This is generated a hash here. And actually, let's pull all this back. I think we see where that hash is being created, and we can see how it's determining if it needs to generate it or not. App is not, yep, okay, that makes sense. Sure, refresh. Okay, so we're back to our list here. We have things, hello, and then an empty one. A third option. This, like, we don't even need to hit save. It just does it all in the background, which is pretty nifty. We have a hash here. So now if we go to our browser here and we instead use this, there we go. So now we've basically forced it to use a specific doc ID, and it's not going to generate it. It's going to use that one. And if we do anything here in our Tauri app, here is a change in the app. This is also synced to the app. This is going over the WebSocket and that public WebSocket endpoint. Again, public, so privacy issues, but basically we're forcing it to use the same document by setting the hash here because we have access to the URL, which we don't quite have direct access to in the Tauri app. So if we have something generate the or manage these docs through this hash, we now have a syncing mechanism that way. Or we can, I mean, it's not the syncing mechanism. It's more we have a hook to basically grab this. So like in your database, you could have a generic user access. Here's a list of docs, and that would be something you could show to the user. So the user loads the app, they'd have a list of docs. They click one, it's going to load. And if we actually look at Automerge and documents, we don't have an easy way to see it here, but can we actually look here? Because we now have a different doc, because we got this Q9 one, this Q9 doc that is. I don't see any actual reference to it, which is interesting. Data may be stale. Okay. So how do I get it to refresh? Refresh? Here we go. Okay. Interesting. Q9. So we have a snapshot and then a sync state. I don't know if it keeps it all in the value, because we got this binary piece. We have the key. Each one of these are docs. So we'd be able to like, we have the Q9 one, we have this 6E one. We can, in theory, flip between any of these docs. Now, like the routing on this is a little bit weird because this really hasn't been built with this expectation. So you'd have to think about it, or you'd have like a list of these docs that a person could click on and sort of go between. So I have to like hit refresh every time because this is actually still loading it from the index.db state. So when we change that hash, it's not actually causing a browser refresh. So there's nothing listening to that hash that then like pulls that persisted state. So we are so this is syncing now right now, right? If we go to this old doc here and we refresh, now we're on the old one. I am curious if we switch to this and then we start doing stuff here. Does this update? And the answer is no, because the hash that it is currently understanding or subscribed to is still that old one until we actually do a hard refresh, because changing the URL, this hash, isn't actually like forcing a refresh and like going through that app mount. And that's because we are doing it outside of like React. When the page is refreshed on that like first mount is when it determines which document it's subscribing to. So we can, what time we got? The question is, how does this work then with or interact with Rust? If we look at, let's see, storage, merge rules, modeling data. So like when we're making a doc, we init a doc. Is each auto merge documents are quite similar to JSON objects. Okay, so we can do like multiple things in here. So we could do a list, and that list can then have, like in this case, we have a task list. That is an array. That array is what do they pull it from app? A complex object. So it's this. Now, that effectively is a ordered sequence of auto merge values. And then like internally we've got these bits. So it will scalar, unsigned integers, strings, timestamps, counters, and byte arrays. So we have a doc. If we would do, and like we can see here, change doc, and then it's doing some work. Here's another change doc. So anytime we're like editing these or changing these, it's doing the diff and doing all the updates in the background. And that's happening on change. So literally every time we key press, it's updating or firing off changes. Now, if we wanted to look at, and then there's a rich text schema. So there's also some handling of that. So let's look at the Automerge repo. What is metrics? Document key. It returns documents and key. Okay, so we can get a list of documents. Import. Imports document binary into the repo. We can find, retrieves a document by ID. It gets data from the local system and then it emits a document event to advertise interest in that document. So that's that functionality. If it has a hash in the URL, it assumes that it can find it and it tries to find it. And it's getting the data from the local system. So that's that persistence. We had to do the hard refresh. Now, subscribe to remotes. So that's the storage mechanism. Storage ID. So we can have multiple storage and multiple remotes. Export. Exports a document to binary format. And like this, in some ways we can enable data ownership, but also it's a binary. So you're gonna have to do some work potentially to like oh, we can do get peers. Interesting. So if we do a console.log get repo.peers, repo.peers, this expression is not callable. It's a get. Okay, so we just do repo.peers. And if we go here, we can do a refresh and we should be able to see, oh, no peers. Interesting. If we go into this and we do a refresh, no peers. We're going to put a pin in that. I think I have an idea why, but we're going to put a pin in that. Okay. I think we're getting a good idea of functionally how this is all operating. Let's close a few things. Now, ephemeral data, I don't think we're going to go into that too much, but that's the idea of like, here's the thing that you want to broadcast to everybody and you want it to show up in everybody's system. So alert or broadcast is a good example of that. You don't really need to keep that state around, or at least the history of that state. Like it's just a send it to all the clients and then you're done with it. So I don't know that there's too much that we need to actually go into exploring there, but I did want to, what is this doc handle? And it does have some like state handling stuff. Okay, so there doesn't seem to be a way that we can like subscribe to changes or anything. Okay, there's an events. Okay, so we do get an events, so we can potentially do an event listener if we wanted to see all the events going out. And that is on repo change. We've got a repo subscribe, delete. I don't see anything that's actually like a, so like we have a document handle events. Handle state, generate. So if we look at like a repo dot, we can emit, add listener. All right. Handles. Returns all the handles we have cached. Okay. Return a list, an array listing the events for which the emitter has registered listeners. So if we do add listener, and then we can have a function. So if we say listener, okay, document, sure. And then let's say, sure, arg, and then we'll just log that out, console.arg. So this would, whoop. This will give us a listener, and now anytime there's any changes, we should see those coming through. Would be my presumption here. Interesting. I don't know if we need to repo add listener. So a doc handle gives us changed it. Okay, so we've got a repo. A repo comes from here, so we do new repo. Pressing the wrong buttons. And then from here we can do handles, so we can get all the handles that we have cached, and that'll give us document ID and then the handle. So if we actually just go here and we say handles, let's look at that. That makes sense. We've got to handle this one. In the ID, we can see the state and log and events. Here's the events. Yeah, and here's a change. Okay, so we can see some of that. It looks like we can potentially subscribe to it. It's the docs. These TypeScript docs aren't terribly clear in how to best go about that. And this doesn't. Once you have a repo with a network adapter and a storage adapter, you can get down to business working with doc handles. Okay. So then in here we're doing use doc. So we've got a doc, and that would be a okay. D.tasks. Okay, so that is specific to that doc based off the URL that we're passing in. Okay. It looks like you can subscribe to the events and sort of like inspect it that way. And I think there's use cases that I'm potentially interested in for that. But what I do want to poke into, I think, is going to be this for communicating between processes in the same browser. That's not going to work for app situations. Sync protocol is point to point and message channel. So it seems like the big way that the networking is going to be handled is through the WebSockets. But I kind of want to dive into that with the Rust stuff. But real quick, actually, I'm going to be right back, and I'm going to grab a drink because I am parched. So 1 sec. There we go. Okay, can't forget that. So then I think probably one of the more important bits to differentiate between each of these libraries is that like networking aspect and how it handles that piece of it. Because again, there's multiple flavors of CRDT, but in effect, what it gives you as the user of a library is some diffing mechanism that should just sort of happen in the background. You don't have to think about it. But how you get that data to other folks is, I think, probably one of the more important bits. So they have WebSockets and they have message channel and broadcast channel. I don't think there's any reason to use either of these. Demo purpose wise, sure, and maybe there's a specific use case for it just in general, but like it's still within the same browser. So yeah, helpful, but also if you stand it up and get it working with WebSockets, functionally you're going to have the same. It's gonna work functionally the same, and then you get that ability to also support, like you could do multiple browsers or multiple computers, Tauri app and browser, any combination of those, as long as you're syncing and pointing to that same document, which is the like tweaking that we need to do to get that working. So there, I don't see any. I guess can we go to, let's go to their repo. I think they have some information in the README as well. Automerge. Because there is, no, I'm thinking of a different one. Yeah. A different implementation. And this is actually an important bit here. I'm going to leave this open because I want to come back to that. But do we not have any other mechanisms to sync? Network peer. So this is the Automerge repo sync server. Here, let's look at this one. A network adapter for WebRTC using PureJS based on the point-to-point message channel network adapter. Okay. So this actually expands on, I guess in some ways that makes this actually more useful. So it's using the message channel network adapter and PureJS in tandem with that. So it's a community contribution that includes a dependency on the PureJS library. Yep, okay, that makes sense. And unfortunately, doesn't seem like it has had a whole ton of attention. A little bit, but yeah. So there's some tests, maybe would be a good way to qualify it. Folks poking around in additional places or areas where we can do some network syncing. So I think with that being said, it looks like here, let's take a look at that pin. We said, let's come back to this. There's a Rust implementation, but But the caveat is the Rust codebase is oriented around producing a performant backend for the JavaScript wrapper. Yeah, okay. So if you want to build a Rust application that uses Automerge, so if you wanted to use Automerge in Rust, they're saying look at AutoSurgeon, which is an implementation of the same in Rust. So if we look here, I don't know that it's going to make sense to pull this in, because I don't know that we need to manage these things in Rust with ours. If we're working in the context of a Tauri app, that sync mechanism is already built expecting to work with a browser. I think it's fine to keep that expectation. And the thing that I might want to run in Rust is like a sync server, effectively, like a local sync server. So this is good to know. And it's good to know that we have the ability to potentially change a doc through Rust. But in reality, we do kind of want to look at the Rust. There's an Automerge WASM, so that's the build that is. Oh, okay. I'm guessing that Automerge WASM is the thing that the repo version is pulling in. If we look at Automerge, nope. Oh, this is the Rust implementation. Okay. So where's that server that they're talking about? The Rust codebase, and this is, I mean, there's some Rust in this library. What is performance tests? Automerge repo sync server. What's this? This server is an unsecured Express app. I wonder if this is basically the thing that they're deploying to do that public sync server. Could be. So it must be in that repo then. Automerge repo RS. What is this? Okay. And I've been keeping an Automerge for quite a while. It still feels like it's a bit in the research phase. I mean, it's working its way out, but it's been around for a while. Like if we look at, I don't know if this is actually going to be representative, but I mean, 3 years ago, it's possible this is actually an old or a newer repo, because I want to say that like they started this a while ago, and they've been working on it for a while, and they actually it says it in the docs. There was where was that? Under the hood, merge rules. I don't remember where it was now. Here. Originally they did it in JavaScript, and then they switched to Rust. So this repo could be as of when they made that switch. So what is let's look at examples. Watch. We have Automerge and get changes. So it still seems like there's, like, if we wanted to run a server, Pause source. And there's a lot going on here. But they're not wrong. You're gonna have to basically read out a bunch of the code, for better or worse. Automerge CLI. It seems like I don't see portions of the Rust implementation that we could actually like use off the shelf. The auto surgeon is potentially helpful if we wanted to edit things in. If we wanted to edit things in the Rust side of things, I don't know that there's a strong use case for it though. If we look here, what else do we got? Okay. Oh, they have a Svelte. Interesting. So we have storage. We wouldn't use Node.fs. IndexedDB is probably the only way that we could reasonably persist stuff. So we're sort of forced into using that. And I don't see any other actual implementations other than this peer.js, which is also in a sort of like beginning researchy type phase, it looks like. Like I made 26 commits. It's new. Yeah, it's new. Which is fine. I mean, you got to start somewhere, right? But I think if we're going to want to use anything with Automerge and Automerge with Tauri and local first and et cetera, we're probably going to be just sticking to using the JavaScript implementation. We could look at, though, what is examples actually? Let's just React to use awareness. Sync. Oh, they got a sync server here. What does this look like? Yeah, and okay. So it is actually doing it's using the same adapters. For better or worse. So like we wouldn't be able to easily dump this into Rust. If we're going to do anything with Rust and that Rust sync server functionality, we are going to likely need to wait for we're going to need to wait for this returning over the next few months. Which is fine. We are playing the long game on this, so I think that probably about settles that. I don't see a way to. We can look at that. Oh, that was not expected. Yeah. Yeah, I think if we're gonna want to do anything with that, we're gonna have to wait for some more of that the Rust pieces to settle out, which is fine. But it does look like we have two options for this network sync. We can use like a centralized server with WebSocket connection, which isn't an awful setup. We would need to then be very specific about the user access and control of that dock. So we would need to stand up or use a service that has auth stuff built into and works in tandem with whatever WebSocket connection we create. So that's either, in any situation you can do completely custom, right? But potentially we could use services for either one or both of those pieces. And like that sync server is basically going to need to be something that we could run in JavaScript at the moment until I think this Rust stuff lands. And this also seems very much like it is in process, but not terribly far along. It's doing changes and it's handling stuff, but it's yeah, I don't see any of this run this in the server, and I think in the same way, we basically need like Rust and the storage adapter. So like we need the equivalent of the. Is it in here? Examples? No. Be in the repo, right? Oh, actually, I've got it open still. This like we need this in. Yeah. Okay. Sure. Makes sense. Share policy. Interesting. We basically need this in Rust. It looks like they've got the run the code in Rust portion of it, but they don't have, or at least I'm not immediately seeing the syncing mechanism portions of it. Nor I mean, like this isn't even linking to. It's linking to their actual like doc sites, so I don't even know if they've published the Rust crates. So we'd have to point to actual get get URLs for some of the Rust stuff if that's the situation. So I don't think we're actually going to be able to dig into too much Rust stuff. At least not the. Like I said, we could do AutoSurgeon, and we could get that working. Like I could copy and paste this, and we could play around with it. But I don't know that there's any added value in doing that because we don't. I don't know that we have this use case yet, or I don't see a use case for it. So Rust here is the Rust implementation and the Rust components for specific platform-specific wrappers. Yeah, WASM API, CFFI bindings. JavaScript uses Automerge WASM. Yeah, I think if we want to do anything with Rust and that syncing mechanism, we would have to wait for that to settle out. Because it doesn't seem like there's peer-to-peer sync. I haven't seen anything specifically stating that, and I think that's sort of the basis of this. You could get two clients to run and sync together. So we've got, if we were using like that message, let's look at networking. There's broadcast channel and message channel. Broadcast channel would work within a browser instance, and basically it's those instances are talking to each other and syncing. So it's using the broadcast functionality within the browser to actually trigger that local state to then do an update. Storage functionally is only a way to persist and pull back. Like it's more of a cache is probably the way I would describe it. So you are pretty much reliant on using the networking portion of it because you can actually pull based off of the networking. You can pull all the data. You're basically syncing external data onto a new or store with no information. So the message channel seems to support the setup with WebRTC/PeerJS, and that would be syncing two documents together peer-to-peer. So we do have some peer-to-peer talking, and then this WebSocket integration would be my system talking to WebSocket sync server those documents get synced, and then that also does a sync to the other client. So we're doing a Tauri app sync to sync service, get those two state pieces in the same like sync together, and then that then syncs back through to the browser tab. So this actually is not just a hop. It's not a like pass through. As far as I can tell, it's not a pass through. It's not the Tauri app talking to the browser through an external source. It's actually another sync hop. So we're doing sync to server, server to browser doc. So it's something to keep in mind. I don't know that it completely removes all possibilities, but it's there's no like message passing type mechanism. You're always like, these two docs are syncing together, which depending on the data and the use case, at least for the stuff that I'm interested in, I don't think it's going to make a difference, because it's such a small amount of data that you can do those syncs at every hop, and the latency between them is going to be rather minimal. So I think that's probably what we're going to call it. I don't know that there's too much more we can do with the Rust side of things, and that sort of puts us in a situation where if we're going to make use of this in any context, we are going to be making use of it like we would effectively need to run a separate service. So if we wouldn't be able to enable like a fully, at least at this current time, a fully like Tauri app local sync service. That peer-to-peer piece could eventually come into play. No, actually, it wouldn't. So Peer.js is a library that does WebRTC. So it would be two clients connecting to each other. Yeah. So it would be, like one browser on one computer and another browser on another computer talking to each other. If we would want this like Rust sync service, we basically need the equivalent of this WebSockets thing in Rust. So we would have to, and then you're basically like, you have a service, and that then means that your app is running something that's at least within that network accessible. Then you start having a lot of like security things to think about, because you're effectively running a server. So yeah, I think if we use Automerge, it's going to be, at least in the context of the things we care about, it's going to be very much just like functionally running it in Tauri versus running it in a browser is not different. You're syncing to something external and it's coming back. It shows up in the browser or in the other slightly different browser that is Tauri. So I think that's what we're going to call it. I think we're going to do YJS next week, pending anything else coming up, I guess. I know we're getting pretty close to Tauri v2. We'll probably do a bunch of upgrade handling that type streams, but there's no hard date set yet. So we'll probably do a bunch of like local first stuff, and then in between that we'll do some launch day type streams, or potentially like working on docs, or doing something with pushing some of the work or things we've talked about on stream up into like the plugins workspace or something. So that's probably going to be a bunch of our topics for the next, handful of weeks. I do want to potentially do a little bit more pure Rust, though, not in the context of Tauri and like embedded or some of that kind of stuff has been sitting in the back of my mind, and I've been waiting on a platform called Turing Pi. I kickstarted the version 2, and I got the shipping notification, but it's for like a month or 2 out. So whenever I get that, that's actually a RISC-V platform. That might be something we will want to play around with a little bit on stream, but we'll see. Probably a bunch of local first stuff and Tauri things for the next handful of weeks at least. So I'm gonna get that scheduled. Hopefully don't screw up my broadcast thing again. The buttons are they put the button in a place that I always click the wrong one, and I have now turned on a prompt to ask me if I'm ready to stream rather than it just starting the stream. Because today I think I started the stream like 10-15 minutes early. Yeah. And then I stopped it, not realizing what I did, and whatever. It's fine. Tuesdays. We're getting there though. We're getting our stream to do is getting settled out. I'll fix up these last little bits of things, and hopefully we can finish out the year solid where I can have a stream where something doesn't go wrong. But until that time, I'll see you next Tuesday for some YJS stuff, likely. Press the buttons, get the notifications, presuming I don't screw them up, and I will see you next week. Thanks for stopping by, everybody. Good to see you, Nicola. Bye.